Hello, this will be a demonstration of Proposition 27 from Book 3 of Euclid's Elements, which states that in equal circles, angles standing on equal arcs will be equal to one another, whether they be at the center or at the circumference. This is the converse of the previous proposition, 3.26. Thus, all we are given are equal circles, ABC and DEF. Something like that. So these two circles are equal, we'll say. We have A, B, C here, D, E, F here. Now we have, of the circle ABC, we have the center G, and of the circle DEF, we have the center H. We're simply given these. And these circles are such that the arcs here, BC and EF, are equal. I'm going to redraw that. So the arc BC and the arc EF in that direction are, or the minor arc, let's say, BC and the minor arc EF are equal. And we have the angles GBC, or that is not the angle GBC, that's the angle BGC. And we have the angle BAC. We have the angle EHF and the angle EDF, like so. What we have set out to prove is that the angle BGC is equal to the angle EHF, and the angle BAC is equal to the angle EDF. These are angles standing on the equal arcs. Now, if this is not the case, if it is not the case that the angle BGC is equal to the angle EHF, then they're unequal and one of them must be greater. So let's say that the angle BGC is greater than the angle EHF. Okay? Now if it is greater, then we can fit an angle equal to EHF inside BGC. That is exactly what we do. We draw the angle BGK such that it is equal to the angle EHF. We do this by proposition 123, of course. Now, we have these equal angles we have these equal angles in equal circles. And so we know that the arcs on which they stand must also be equal. This is proposition 3.26, the prop we just did before this. And so we then know that the arc, or the minor arc BK and the minor arc EF must be equal because we have equal angles standing upon them. And we are given that the minor arc BC and the minor arc EF are equal. And so by common notion 1, we know that the minor arc BK and the minor arc BC are equal. But we also see clearly that that the minor arc BK being a part of the minor arc BC, by common notion 5, must be less. The minor arc BK is a part of the minor arc BC. And so the arc BK must simultaneously be equal to and less than the arc BC, which is obviously absurd. And so the angle BGC cannot fail to be equal to the angle EHF, and so the angle BGC is equal to the angle EHF. Now we know by proposition 320 that on the same arc, the angle at the circumference is half the angle at the center. So we can say that the angle BAC is half the angle BGC, and the angle EDF is half the angle EHF. And the halves of equal things being equal, that's a property of magnitudes. The halves of the equal things we have here are the angle BGC and the angle EHF, and we have their halves, the angle BAC and the halves and the angle EDF respectively. And so we can also say that the angle BAC is equal to the angle EDF. Now this being what we set out to prove, we are done with the proposition, therefore, etc. QED. Again, nothing to say about this proposition, so I will move on to prop 328.